Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. Hey everyone, in this video we're gonna learn about these different abbreviations which we can find on a molded case circuit breaker and also air circuit breakers. AF, AT, FTU, and so on. So let's start with the first one, AF. So this is an abbreviation for ampere frame. So what's exactly ampere frame? This is the physical size and thermal capability of a circuit breaker. So this representing the maximum current that the breaker's body is designed to handle, regardless of the actual trip settings. Now this actually representing the mechanical and thermal limit of the device structure itself, the circuit breaker structure, bus bars and its contacts and enclosure. And these are different ratings for ampere frame. So let's understand what I exactly mean. So we have two circuit breakers. These are two circuit breakers. One of these circuit breakers has an ampere rating of 80 amperes. This is the IN or the nominal current, or IR the current at which it will start to activate in the overload case. This one has an ampere rating of 60 amperes. So this is 80 amperes and this is 60 amperes. If you look at these two circuit breakers, from their look and their size, they are exactly the same. These two have an ampere frame of 100. You can see 100 and 100 amperes. What does this mean? It means that we have this structure, this exact structure, until 100 amperes. So we have different circuit breakers. This structure with these dimensions is available until 100 amperes. So we have different ampere frames that can withstand certain amount of current. So this frame here can withstand up to 100 amperes. There is another one which can handle 150, another one can handle 160, and so on. Let me explain this more. This from a catalog here, from a circuit breaker's catalog. This one is a frame. You can see a circuit breaker size. This size and this structure can withstand up to 100 amperes. It is available. Its ampere ratings, the trip settings, can be between 15 to 100. So we can have a 15 ampere circuit breaker. We can have 80 ampere circuit breaker, 100 ampere circuit breaker. All of these have the same exact size. Now, if we would like to go further beyond a larger size, then we will have up to 150 ampere. This will be between 40 and 150. This is simply the size and the maximum current that this structure can withstand. You can see as the ampere rating increase, the maximum ampere that the structure can withstand, the contacts, bus bars, enclosure, as this size increase, the size of the circuit breaker dimensions starts to increase. So why is this even important? Because if I have a circuit breaker, let's say of a 32 amperes, and I would like to upgrade my circuit breaker, I would like to replace it, let's say with a 63 amperes. So in order to change it, I have to get a new circuit breaker with the same size. So how I would know this size? From this frame. So if it is a 100 ampere frame, then I am gonna get a circuit breaker with a rated current or nominal current of 63 amperes and the ampere frame of 100 amperes, so that it can fit inside my own location. The next one which we would like to discuss is ampere trip. Remember that 63 amperes or 80 ampere, this is the trip current. This is simply ampere trip, called ampere trip 80. This is the adjustable which we can change based on what we are gonna see in the next slides, or it can be fixed for the actual overcurrent protection. So this is the value of current at which the breaker will start to open the circuit after a certain amount of time, dependent on the increase on current beyond this value. So let me explain this. So these are three circuit breakers. If you look at them, you will find that this is an 80 ampere. So this is the current at which it will start to activate. So if you remember, a circuit breaker would be like this. It will have the overload curve, and then it will start having its own short circuit like this, at which it will start operating quickly. This current is called ampere trip or IR or I nominal. This is the rated current of circuit breaker. When the current exceeds this, it will start, circuit breaker will open after a certain amount of time, dependent on the increase of current from IR. So as the current increase, you can see that the time taken to close to open the circuit breaker will start to decrease until we reach the short circuit position. Here this one is 60 amperes, this one 200 amperes, and for the frame 100 ampere frame, this one 250 ampere frame. I obtained this from the catalog of the company itself. This is another one, here 100 ampere frame, and you can see operates at 100 amperes. Okay, now the first point which I would like to discuss is that if you look at these circuit breakers down here, let me delete this, you'll see something which is interesting. You can see FTU here, FTU, and here is an FMU. Here is an FTU. So what does these abbreviations mean? These are related to the trip unit inside the circuit breaker. So what I mean by this, if we have a circuit breaker like this, it has its own overload and short circuit, right? Overload characteristics and short circuit characteristics. Now, there are two options here. The first one is that these characteristics are fixed. What I mean by this is that the overload will start at IR, a fixed IR. And also the short circuit, which is magnetic, will start at a certain value called IM. So these are fixed. In this case, when these two are fixed, we say FTU, which is a fixed trip unit. It means I have no control on IR value or IM value. They are exactly as they came from the company or the manufacturer. So you can see that here FTU, the curve here given, if I zoom in like this, you can see 80 amperes. This is the IR. You can see there is no option here to adjust these value. And you can see II, and in other one like this, IM, this one IM, meaning the magnetic value at which the magnetic circuit or the electromagnet will start activating, or short circuit protection, quickly activate in the fastest possible time. So you can see these are two values which are fixed here. I can't change them. That's why fixed unit. Now there is another one, okay, this one here called fixed magnetic unit. It means that the magnetic part IM, I can't control it. However, the IR, this value, I can control it. As you can see, I can change it from 80%, 90%, or 100% of the given value. For example, if I put it here at 80%, it means that the rated current it will start activating after is 80 amperes. If I put it like here, it means at 90% or 90 amperes. It means that IR will be 90 amperes. One meaning I'm taking 100% of the value. So this is a semi-adjustable. I adjusted the IR value. However, I don't have control on magnetic. That's why called fixed magnetic, because magnetic itself is fixed. Because we know that this overload is related to a thermal protection using bimetallic strip, and we know that IM or the short circuit protection is related to electromagnet protection. or magnetic protection, which we discussed them before. Okay, so let's get back like this. So fixed trip unit here, a non-adjustable trip unit built into breakers with a preset tripping threshold at fixed values. So they are factory set and cannot be changed. Fixed thermal and magnetic unit mean that the thermal values or IR fixed, magnetic fixed IM. There's another circuit breaker, as you can see, also the same thing, IR and IM fixed. This is another one, FTU, fixed trip unit. I can't change these values. So as you can see, 150 amperes, II or IM like here, activated at 10x the 200 amperes. 10x the 150 amperes. Okay, here 10 times the 80 amperes. Here 800, 2000, 1500. Mean that the short circuit protection is activated at IN multiplied by 10 times the current, the nominal current. The fixed magnetic, it means that the magnetic part is fixed, but the thermal can be adjusted, like here the one that I just discussed before. Okay, now let's talk about another one called magnetic trip unit. This is what I mean by magnetic trip unit. It means that our circuit breaker, you have seen in the previous slide, we have overload and then we have a short circuit, right? So we have a thermal unit and we have a short circuit unit. One which we cannot change, which is the FTU, fixed trip unit, and one which we can only change the thermal and we have no control on this one, called the fixed magnetic unit, right? Now there are other type of circuit breaker that only contain this short circuit value or short circuit protection. It does not have any overload. Overload does not exist. This type, which does not have overload, called magnetic trip unit. So the magnetic trip unit is a breaker trip unit inside the miniature, the molded case circuit breaker that has only magnetic or instantaneous protection without any thermal overload protection. Okay, let's delete this. As an example, this one you can see MTU. This is an molded case circuit breaker, MTU. If you zoom in like this, you will see magnetic trip unit, meaning that you can see short circuit only. There is no overload here. We can see only IM, IR does not exist. And not only this, you can see that we can control IM value. So it is adjustable in this circuit breaker. You can see we can activate it between 960 and up to 1920. So we have control on the short circuit value or short circuit protection. So that molded case circuit breaker with an MTU usually used in feeders and general circuits when we have an external thermal overload, or overload is managed with an overload relay, an external relay, another unit. Now, what about motor circuit protector? Now, this is very important. Motor circuit protector is simply a molded case circuit breaker specifically designed for motor protection. It follows the standards and it is designed for the inrush current for large motors. Now, motor circuit protector is same as the molded case circuit breaker with MTU. It has only magnetic trip unit, and the overload is managed externally. So motor circuit protector is type of molded case circuit breaker with only a magnetic tripping. Means it is used for motor short circuit protection. It is used in motor starters and motor control centers. Now let's look at this. So this is what we have as a MCP or motor circuit protector, and this is the overload relay. This one is used for overload protection, for overload with an overload relay. This one is used thermal overload relay, used for motor protection against overload, and this one used as a protection for short circuit. Combined together, they provide the full control or full protection against overload and short circuit for motors. So these are designed specifically for motors. These are for general application. These two, or this one specifically, follows the standards for motor protection. Now there is another one called adjustable trip unit. What is the difference between them? It is pretty simple. So we have here overload and again short circuit, right? We said FTU, we don't have any control. We said that FMU or fixed magnetic unit, we have a fixed magnetic and we can control overload. The adjustable trip unit provides both. What I mean by this, it gives us an adjustable thermal or overload protection and also adjustable short circuit protection. It means I have a control on IR and IM, both of these values. So this one is adjustable long time, which is the thermal, short time and instantaneous magnetic protection. So if you look at this circuit, you can see it has an ATU and an adjustable trip unit. You can see both of IR and IM. You can see IR, how much of the nominal value. So let's zoom in like this, magnify this slide. You can see IR, which is this value, is equal to how many times of IN nominal current, which is 150 ampere. For example, it can be 80% of 150, 90% of 150, or 100% of 150. For the IM or magnetic protection, short circuit protection, it can be 5 times this value or 6 times until 10 times. So you have a more flexibility on selecting these values. Okay. Another thing that I would like to discuss is that if you look at a circuit breaker in manufacturers, you will find 100N. We said that 100 here representing the frame ampere. Here 150 frame ampere or ampere frame to be more specific. And we have a letter here, L, and we have N. So what do these letters represent exactly? So according to the same manufacturer, it says that, hey, look at what type of frame you are using. Okay, so let's look at this one. This is 100 frame. Okay, so I'm talking about this one here, right? 100 ampere maximum rating current. This is for the frame itself. Okay, how many poles? This is the 3-phase. So we have to select this one. So these are exactly the same, except that this is for a 3-phase. This is for a single phase. So what I'm gonna do is that I'm gonna delete this and say I'm gonna focus on this part only. Okay. Now the next step, the breaker type, is it E or N? This letter here, N. So it means I'm gonna look at this column here. Now, what voltage you are operating at? If you look at here, let's say, let me zoom in or magnify like this. You can see we have different values, 240, 480, and so on. So let's say I'm gonna operate at 480 volt. So if you look at here, N 480 volt, if I go like this, it will be 35 kilo ampere, which is the short circuit breaking capacity, the maximum short circuit it can withstand, interrupting capacity, 35, which is the same value here as you can see, 35. Similarly for this breaker 100E, if you look at E, go down here, 25. So let's see if it's 25, 480, 25 kilo ampere. This one 150L, 150L will be 100 kilo ampere. If you go down here, 480, 100 kilo ampere. So this is the meaning of these letters, and also the values are even given on the circuit breaker itself. Okay, so let's continue. So let's look at, this is a circuit breaker from the website of the manufacturer itself. You can see 100 ampere circuit breaker. This representing I rated, right? The rated current or the nominal current IN. 3 poles mean that it's for 3 phase, 1, 2, 3. Molded case circuit breaker. Thermal magnetic, it means that it has the thermal protection. If we zoom in like this, you can see thermal protection, overload, and short circuit protection. UL, okay, this is the standard follows 150 ampere frame. You can see 150, this is the frame maximum. Ampere will reach up to 150 ampere for this model here. Now another thing that I would like to see is the inside that data sheet, which you can find in the files for this breaker here. So you can see this is the thermal trip and this is the magnetic trip, okay, for these two. Now look carefully here. Let's magnify. So if this unit is a fixed trip unit, it means there is nothing adjustable. I can't adjust 40 amperes, then the IR 40 amperes, 50 amperes, then IR 50 ampere, and so on. Now for the magnetic trip, this is the value at which it will be activated for a short circuit. For a fixed magnetic unit, exactly the same. However, for the IR, it is adjustable, as you can see, from 80 to 100%. You can see 80 to 100% adjustable, as you can see. Now there is one important part here, which is this one. You can see between 80% and 100%. What does this mean? This is the tolerance provided by the manufacturer. So what does it exactly even mean? It means that this one, let me get back like this. So here the manufacturer says, hey, the short circuit protection activates at 500 amperes. However, due to different factors and due to testing and different settings, you will find that in the end, that this is not exactly the value at which it will be activated. It will activate between 80% of 500 to 100%, 160% of the 500. This is the range at which it will actually activate. What value exactly, we don't know. It is between this range. So it is not exactly 500. It is between 80% of 500 to 130% of the 500. So we are not certain it will activate at 500. It will activate even at less or greater or between them. Okay, so this is that tolerance provided by the manufacturer. Okay, so to summarize, these are the trip units that I discussed in the video: fixed magnetic adjustable trip unit, magnetic trip unit, and their settings, their applications, and their advantages. There is another one which is electronic, which I didn't discuss before. Maybe we can discuss it in another lesson.